everyone. We are just for fun. Our members are Shinyu, Kanehumi Matsuyama, Rinyoichi Takezoe. Here is our design for the Mahjong programming. We will show three parts of the report. The first part is an introduction to the Chinese standard Mahjong. The second part is the detail of the offense algorithm. The third part is the detail of the defense algorithm. Here is an introduction. Firstly, we introduce the game features. Mahjong is a dynamic game with incomplete information. There are 4 players in the game. Each player has a symmetric of information. The main reason why the symmetric exists is the randomness of the tile war. The game is a Chinese standard Mahjong. It is the international and the domestic recognized Mahjong game. Its special feature is that it has 81 kinds of winning hands and limits to win at least 8 points. So there are 81 ways to win, and each way has its point. The limitation says that 81 ways eliminate the points of ways are less than 8. The limitation also adds difficulty and interest. The game eventually realizes on a competitive level, not the luck. It takes numbers of games to distinguish a player's competitive level due to the randomness of the tile war. The more the game times, the smaller the Mahjong luck component, the more conversion to a real level. So games are becoming more and more interesting to study, and there are more and more research recently. Then we introduce the key and difficult points of AI design. In key points of our design, our algorithm is based on expert knowledge. We observe a lot of human data provided. Then we discover that tips for increasing your chances of winning the game. But the fundamental framework is based on the research theory, card effect theory, something number theory. On the other hand, our algorithm focuses on both offense and defense. In particular, how to get a winning hand and how to prevent other players getting a winning hand. In difficulty of our design, the related research investment as well as the theoretical basis is little. So some of these techniques are based on analytical experience rather than a very good theory. And as a history of Mahjong, there are also lots of traditional algorithm templates that can win fast and disassemble cards. However, due to the very large consumption of the limitation of 8 points, these algorithm templates cannot use in the game. So we should implement this function by hand. Of course, this operation in real world is different in the programming. So the Mahjong game process is abstracted into state and action conversion by ourselves. There are numbers of human data. It is the hard work to process and analyze the data, and then discover the tips. Well, let's enter the second part, the offense algorithm.
Then we'll talk about the offense algorithm. This part includes the basic idea and optimization. Our offense strategy is based on the card effect theory. There are 2 important concepts in this theory, shunting number and the effective card. Shunting number is the card number you need change to shunting. Effective card is the card that can move forward the drawing hand. Technically, we can go towards the direction of the drawing hand each time. However, because of the 8 points boundary, we should prevent the error winning. Our approach is to adopt different strategies according to the shunting number. When shunting number is greater than 2, it's far from the status of the drawing hand, so we directly reduce the shunting number. In other words, we select the card which has the smallest shunting number and the largest number of effective cards in each round. One shunting number is less than or equal to 2. Considering the limitation of 8 points, continue with the previous strategy is likely to be the arrowing. Therefore, we use the search tree to find the best solution. In the first layer of the search tree, we traverse different hand cards to consider which card our boat plays. In the second layer, we think about all possible cards we draw after the first layer of the simulation, and so on. When the algorithm discovers the winning hand in the branch, it computes the points of the winning hand. Back to the current decision, we select the branch which has the most effective winning hands. During the experiments, we found this method has some disadvantages. First, due to time constraints, the number of layers in the search tree should not be too deep, which may lead to a wrong decision. Secondly, although the detection of the winning hand has judged the limitation of 8 points, but cannot prevent the boat to calculate some ways of the shunting number which cannot reach 8 points, leading to the choice of arrowing. In order to improve these problems, we tried the one-step greedy method. It's very simple that whatever is the shunting number, the boat will decide to go towards the drawing hand. If we found the drawing card illegal when we shunting, we will play the card to increase the shunting number so as to try other solution. This method achieves a slight performance improvement. Then we try another method. We have counted about 30,000 matches and found 7 kinds of winning hands, which over 6 points, commonly occurring, as shown in the figure. These 7 kinds have a total probability of 76% in the 30,000 games, which means that these seven kinds include most legal winning hands. So we try to only consider these winning hands in the game. This method achieves the best performance in the end. Finally, we improve some details, such as the selection of effective cards. We found that the different winning hands may have the same number of effective cards, but type of effective cards are not equal. In this case, we should choose the branch which has more types. In addition, because the score of gun is higher, so when the shunting number is equal, whether gun or not, we should give the gun priority.
Finally, let's explain the defense algorithm. When we use a strategy that reduces the shunting number, there is the situation that the shunting number and the kind number of effective cards are equal. So there are still a variety of play options. Under decision of offensive strategy, we add defensive strategy and consider safety card with the highest safety factor to reduce the probability of discarding. Meanwhile, we add a special rule. When our boat draws the last card on the table, if it finds that the card is not legitimate, it will directly play the safety card. As above shown, a card with a effect of safety is called a safety card. The higher the safety factor, the less easy it is for other players to 吃碰干胡. In particular, we define the array recording the score as a safety factor. Traverse the cards in the discard pile. Count the cards and get a score, which is the current safety factor. On the other hand, we analyze the card played by other players in the last 3 rounds. We found that those cards have the highest safety factor, And then we set the same safety factor for cards that are 3 away from this card. It prevents being 吃. The closer to the current turn the card is, the safer it is. In addition, we found the stage optimization of the defense algorithm when we implemented the basic method. In the basic method, we set the same safety factor between a card that is played and a card that is 3 away from it. However, we discovered that there is difference in precedence between them. Identical cards have higher priority and security than cards that are 3 away. So we add this tip to the defense algorithm. So our algorithm is shown above. That's all. Thank you for listening.